All right, kids, we're going to take a look at 11.3 day 2. It's just an add-on to what we did yesterday. So normally when you have data, they don't tell you, it doesn't land perfectly on 1, 2, or 3 standard deviations. It can be somewhere in between. So we have this chart that gives us a percent, which also tells us like the probability that is underneath that graph. So let me show you what I'm talking about. First, though, we need to shrink our data to fit onto this one -3 through 3 chart. So we use what's called a z-score. And again, if you take like AP Stats, AP Psych, you're going to be familiar with a z-score. The pieces you need to know will be the mean, which will be given in the problem, your standard deviation, which will also be given in the problem. And then this is going to be the number that they're asking about. That's like the number that's in question. And then Z is going to be the number that you can look up on the chart. Now, the chart tells you how much, like what percent or probability of from whatever line you land at. So say your Z-score is here, it reads to the left. So your chart data shows the probability to the left. So this is to the left of whatever your Z is. So you're going to have to do some thinking sometimes to figure out what part are you actually looking for. Keeping in mind, now these are written as decimals, not percent. So the whole thing is 1. And so we can use that to our advantage later if we have to. Oops, sorry. Okay, so let's just try an example, and there's just one. So we're just doing this one example, and then you'll know everything in the world. Scientists conducted aerial surveys of a seal sanctuary and recorded the number of seals. So X is the number of seals observed during each survey. The number of seals observed were normally distributed with a mean of 73. So that means X bar is 73 in our formula. Standard deviation of 14.1. So those are the two pieces that we're going to need up here in our Z-score. So this is how you do these, similar to yesterday. It says find the probability that at most, think about what that means. That means less than 50. So we're looking for the probability that the number of seals is less than 50. Well, I can't look up 50 on a chart because it only goes from -3 to 3. So I think about what that's going to be on my chart, but first I need a Z-score. So the Z will shrink it down to be in between that -3 and 3. So the number of seals they're asking about is 50. I'm just going through my formula up here, minus, and then they told me the mean was 73, and then they told me that the standard deviation is 14.1. So when I do that, I get -1.6. And what that's telling me is I'm on the chart at -1.6 standard deviations. So I go to the chart, and I'm going to remember from yesterday, the mean is in the middle. -1.6 is going to be over here somewhere, and less than is going to be to the left. Since it's to the left, I can use the chart value. So whenever X is less than, I can just use the chart number because the chart reads to the left. So I go to my chart, and I'm looking in the negatives. This is 1, and then I need 1.6. So I go back to -1.6, and where those numbers overlap, that's going to be my probability, 0.0548. Now, yesterday we did percent most of the time, and so that would scoot over. If you wanted to call that 5.48%. Honestly, I just leave my answers like this if I'm reading them off the chart. Okay, let's look at some other things that can happen. Find the probability that it's more than 82. So now we're going to have X being greater than something, and we cannot use the chart number because the chart number, let's say X is going to be greater than, well, let's find out. X is going to be greater than 82 seals when they just fly over. So I have to figure out where does that land. So let's find a Z-score. 82 is the number we're talking about, minus our mean of 73 over our standard deviation of 14.1, and that leads me to a Z-score of 0.6. It comes out to be like a bigger decimal than that, but I only have room for a tenths place, like 1 decimal place up here. So this is going to be on the chart, meaning I'm just a hair, like 0.6 to the right of the mean, but I'm looking for the number over here, the bigger than. So in this scenario, when you have greater than, you have to do 1 minus the chart number, because you're not looking for what the chart's going to give you, you're looking for the rest. So you take the whole thing, which is 1, and then you minus what you find on the chart. So let's go find ourselves a chart number for 0.6. So we're going to go to 0, and I know this is weird, but because we're on the positive side with a positive 0.6, we use the positive 0 and the 0.6, and that tells us the number we're looking for on the chart is 0.7257. But that would be this area to the left, and we need the part on the right. That's why we did 1 minus. So our actual answer is 0.2743. That's the probability of ending up in this blue zone, having more than 82 seals on the beach when they go by. Last one is going to be a between, because those are the only things. It can be less than, greater than, or between. So if you have x between two numbers, you're looking at a chart where it's like this. You're going to take the big Z score and subtract the small Z score. Because what's happening is if the big Z score goes from here over to the left, and then the little Z score goes from here over to the left, you subtract them and find the difference, you're going to get the in-between part that you need. So here when it's like, what's the probability that there's somewhere between 69 and 100 seals on the beach when they go by? I need a Z score for this, and that's going to be my small one, and I'll need a Z score for this bigger number. And then I'll subtract them. So up here, if it's between, you're going to take Z big minus Z small. So let's find the Z score for the low end. I'm going to have 69 minus 73 over 14.1, and that's a Z score of negative 0.28. I'm going to look that up on the chart. And actually, I shouldn't call that Z's up here because you're not using the Z values to subtract. You're going to take the big chart number and then subtract the smaller chart number. Okay, so let's find that one for the bigger end. I'm going to take my 100 minus 73 over 14.1. So all I'm doing is shrinking that data down so I can look on the chart. And now I'm going to do that. I'm going to go to the chart, and I'm going to find that upper end number, and I need to do 1.91. So I go to 1, positive 1, and I go over to 0.9, and that chart value is 0.9713. Then I need to subtract the smaller one, and that's a negative 0.28. So I go to, so really if I'm looking it up on the chart, it's negative 0.3 because I can't look up 2 decimals. So I round it to negative 0.3. Going to my chart, because it's negative, I go to negative 0 and then 0.3. So the number I'm looking for is this 0.3821. And then when I subtract them, my probability of that happening is 0.5892. So the thing to keep in mind is mainly up here, to be honest. When you are looking for a less than, find your Z-score and then use the chart number. When you're looking for something greater than, find the Z-score and do 1 minus the chart number. When you're looking for a value that's in between, find both of the Z-scores, look both of them up on the chart, and then subtract the bigger one minus the smaller one. And that's it.